Hello everyone, you're welcome to this lesson. In this video, you're going to solve this question I have on the screen. The question says two forces P and Q act on a boat A. Determine their resultant force. So let's look at how you are going to solve this question. Okay, so I will start by redrawing the force system that we were given. Okay, so let's look at that. So let's consider this to be the boat A. Okay, that is the boat A. And then what I'll do is that I want us to apply the first triangle approach here. So what I'll do is that I'm going to arrange the forces in a tip to tail manner. Okay, let's look at what I mean by that. So I'm going to start with the force P. Okay, so let's take this to be our force P. Okay, and then this force P, okay, makes an angle of what, 20 degrees with the horizontal line there. Okay, so you're going to have 20 degrees here. Okay, to make 20 degrees, it will make an angle of 20 degrees with the horizontal line. So that's the 20 degrees. So now let's focus on the next force, which is what? Force Q. So for force Q also, let's take this to be our force Q. Okay, all right. And then let's look at the angle that force Q will also make with the horizontal axis. So from the figure here, you see that force Q will make an angle of what, 25 plus what, 20 degrees with what, this horizontal line here. Okay, so therefore the angle that Q will make with the horizontal axis will be 45 degrees. You're going to have 45 degrees here. Okay, so when we do this, what you're going to do next is that you are now going to join, okay, the tail of force P to the head of what, force Q. Okay, let me just name the forces. This is P and then this is what, Q. Okay, so you are going to join the tail of force P to the head of what, force Q. Okay, so let's look at that. So I'll join them with this arrow. Let me draw this again. Okay, with this arrow here. Okay, so the magnitude of that arrow becomes the magnitude of what, the resultant force. Okay, let's take note of that. So our main goal here will be to find this value r. Okay, so let's look at how you are going to do this. Okay, so let's come back to the figure that we have drawn. So from this point, if I extend this horizontal line here, okay, you will see that we are going to have an angle of what, 20 degrees here because of the z angle that we are going to have there. Okay, and then from there, let's find the value for this angle here. So we are going to have an angle on a straight line here. Okay, so subtracting 45 from 180, okay, that's going to give us a value of 135. Okay, so that tells us that that small angle there, let me just undo this. Okay, so that tells us that this angle here is going to be 135 degrees. Okay, so at the end, the angle opposite to the force r, which is the resultant force, will be equal to the angle, okay, will be equal to 20 degrees plus 135 degrees. Okay, and then this will be equal to 155 degrees. Okay, so now let's look at how you are going to find the resultant force. Okay, so we know the value of Q to be equal to 60 Newton. We know the value of P to be equal to 40 Newton. Okay, so what you're going to do is that you're going to apply the cosine rule here. Okay, so let's look at what you are going to do. I'm saying that you are going to apply the cosine rule because we know the value of two sides and then we want to find one other side. Okay, and then we know the angle that is opposite to the side that you want to find. So in this case, you can use the cosine rule. So from the cosine rule, we are going to have the equation r squared equals p squared plus q squared minus 2pq multiplying cosine of the angle opposite to the resultant force r, and then that angle is 155 degrees. Okay, this is what you're going to have. Please, if you don't know about the cosine rule, you can check in the description. I have a link to a video that I explained, the cosine rule and then the sine rule. So please check that video out in order to understand and know when to use the cosine and then the sine rule. Okay, so let's continue with this. So because you know the value of P, you know the value of Q, we can just do the substitution and then solve for the resultant force R. Okay, so let's look at that. You're going to have R squared to be equal to P squared, which will be 40 squared, okay, plus Q squared, which was 60 squared, okay, minus 2 multiplying 40 times 60, okay, cosine of 155 degrees. Okay, so let's simplify this and see what you're going to get. So you will have R squared equals, let's look for the value of 40 squared plus 60 squared. Okay, I'm just adding those two at once. That gives us a value of 5,200. Okay, and then minus, let's look for the value of 2 multiplying 40 times 60. That also gives us a value of 4,800. So minus 4,800. And then we multiply this by the cosine of 155 degrees. Okay, so now let's find the value of cosine of 155 degrees. Okay, let's look for that value. So let me write this first. We have 5200 minus 4800 multiplying cosine of what? 155 degrees. So let's look at that. So cosine of 155 degrees will give us a value of minus 0.906. Okay, that's what you are going to get. So let's simplify this. So we're going to have R squared to be equal to 5200. Okay, and then you see we have negative here, we have another negative here, so you know that you are going to have a plus sign then. Okay, so now let's find the value of 4800 multiplying 0.906. Okay, so let's look at that. So 4800 times 0.906, that'll give us a value of 4348.8. Okay, so let's add these two values and see what you're going to get. So we have 5200 plus 4348.8. That'll give us a value of 9548.8. Okay, and then we have to take the square root of this value. Okay, so we're going to have R to be equal to the square root of 9548.8. Okay, so let's look at what you are going to get for R. So the square root of this value will give us a value of 97.72 Newton. So 97.72 Newton. Okay, so this will be our answer. So that will be the value of what? R. Okay, so one thing you have to know is that this resultant force is at a certain angle from the horizontal axis. Okay, so you have to calculate for that angle also. Okay, that angle will be the angle from this horizontal axis towards where the resultant force is. Okay, so you have to find this angle here. Okay, so let's look at how you are going to find that angle. So now we know the value of R, which is 97.72 Newton. Okay, so what you're going to do next is that you're going to calculate for the angle that the resultant force makes with the horizontal axis. Okay, so let's look at how you are going to do that also. Okay, so for the angle that you want to find, okay, let's consider this small angle here to be angle A. Okay, so the angle that the resultant force makes with the horizontal axis will be equal to 20 degrees plus angle A. Okay, which is this small angle that we have here. So let's look at how you are going to find angle A. Okay, so to find angle A, we are going to apply the sine rule here. Okay, so let's look at what you are going to do. So in applying the sine rule, because we know the value of the side, opposite to angle A, which is for scale, we can use that value, okay, in addition to the resultant force, because you know the angle opposite to what the resultant force, so we can use those values to find what angle A. Okay, so let's look at what you are going to do. So you're going to have sine of A, okay, divided by the side opposite to angle A, and then that is what Q. So sine of A divided by Q, then that will be equal to, we know the angle opposite to the resultant force, so we are going to use that angle also. That will be equal to sine of 155 degrees divided by the resultant force. Okay, so we're going to use this. We can't use this side here because we don't know the angle there. Okay, if you knew the angle, you could have used that also, but we don't know the angle there, so we can't use that to solve for the angle A. So let's substitute in the known values. Okay, so we're going to have sine A, okay, divided by Q, which is 60 Newton, equals sine of 155 degrees divided by R, which is what? 97.72 Newton. So sine A, okay, will be equal to sine of 155 degrees divided by 97.72 multiplying what? 60 Newton. Okay, so let's simplify this and see what you are going to get. So before that, let me just free up some space. Okay. Alright, so let's simplify this. Okay. So we're going to have sine A, okay, equals, let's find the value of the sine of 155 degrees, okay, divided by 97.72, okay, multiplying 60. So that's going to give us a value of, I'm setting this to 3 decimal places, okay, so that's going to give us a value of 0.259. Okay, this is what you're going to have. So angle A will be equal to the sine inverse of this value. Okay guys, so now let's simplify this. Okay, so angle A will be equal to the sine inverse of 0.259. So let's find the sine inverse of that value there. Okay, so when you do this, you're going to have an angle of 15, okay, 0.04 degrees. So let's just make it 15 degrees. Okay, so the value of A will be equal to 16 degrees, and then we know that the angle that the resultant force will make, which is phi, will be equal to what? 20 degrees plus what? Angle A, right? So at the end, phi will be equal to 20 degrees plus 15 degrees, okay, and then that will be equal to 35 degrees. So the resultant force will make an angle of what? 35, sorry, the resultant force will make an angle of what? 35 degrees with the horizontal axis. So at the end, we are going to write the resultant force as 97.72 newtons angle 35 degrees. Okay, so that will be the value for the resultant force and then the angle it will make with the horizontal axis. Thank you very much for watching this video. Please, if you find this video very useful, kindly like the video and subscribe to the channel if you are new to the channel. Thank you.